What are we going to do first? Any ideas? Let's discuss this. I like that. Does everybody hear what Miles said? You always want to see if you can change something to be in terms of cosine and sine. So he made a very good point that cotangent is the same as cosine divided by sine minus cosine cubed times 1 over sine. I agree with that. I think that is a very good start. A very good start. Now, I want to remind you, do you remember this from middle school? Please excuse my dear Aunt Sally. Do you remember that? That never goes away. It doesn't matter how high you get in math. You can get to the highest level, whatever that is. I don't even know what that is. And that PEMDAS will always matter, okay? So what I want you to notice is that we have two operations. I have subtraction and I have multiplication. According to PEMDAS, what do I do first? Do I subtract or multiply first? Multiply. So let's do that. I'm going to put this over 1. Let's multiply this together, which is going to give me cosine over sine minus cosine cubed over sine. I agree. I think we're on the right track here. So now we have subtraction left. What do you have to have in order to subtract fractions? Do I have a common denominator? All right, so that's good. So I'm going to bring this together and make it one single fraction. Just like that. Now, this is where most people get stuck because they don't see what you can do in the numerator. But there is one of the basic factoring maneuvers, like the first thing you probably learn when you learn how to factor is find a what? GCF. There is a GCF in that numerator. So if I were to write this as u, which I don't think, this is not one where I would normally do a u, but if I do u minus u cubed, do you agree that I have a GCF of u? And if you take out a u, whenever you take out a GCF, this is the algebra literacy that some of us are missing because of COVID. But when you take out a GCF, you are dividing. That's what you're doing when you take out a GCF. So if I were to divide, then I would be left with 1 minus u squared. Okay, does that make sense? So I'm going to do that, but now I'm going to put the cosine. So what I'm doing in the numerator is I'm taking out a cosine x. And that's leaving me with a 1 minus cosine squared x all over sine. Okay. There is a move. What is our next move? One of the identities. I agree. And I did write them over here also. But 1 minus cosine squared equals what? Sine squared. So let's do that. So I have a cosine x times a sine squared x all over sine. And when you have sine squared, that simply means that you have two of them. So I have a cosine times sine all over a sine. I had to squeeze that in there. That's what I have. I just rewrote it. And now what? Can anything happen? Yes, Robin? Cancel out one sine. And what is that going to leave me with as my final answer? cosine x times sine x. And now we are to a spot where there is nothing else I can do. I don't have an identity. I mean, I could write them as 1 over cosecant times 1 over secant, but that's stupid. That's not going to do anything. So for what? So we're done. When you simplify, simplifying is harder because you don't know where to stop. But when you run out of things you can possibly do, then you're done. Okay? All right, let's do one more. Now let's do a verify. Go ahead and copy this one down. It looks scary, but I promise you, it's really not. Okay. So, again, we got our order of operations here. Please excuse my dear Aunt Sally. So we start off with parentheses, but there isn't anything I can simplify inside of my parentheses because are these like terms? No, so we can't do anything with parentheses. Okay, but do we have exponents? Yes, so let's do exponents. Now, what I want to make sure you understand, this is, again, one of the algebra fluency things that some of us are missing, is you cannot do this. You cannot say that this is sine squared minus cosine squared. That is not how you square when there are two things. You have to make a box. We have to make a box. So you're going to need to make two boxes. In the first box, I'm just going to use S and C. You're going to take S minus C times S minus C. And then you're going to make another box. And in the other box, you're going to take S plus C times S plus C. So go ahead and do that. Fill in your 8 squares, combine your like terms. The sub found a missing bracelet. So if someone is missing a bracelet and you describe it to me, I will give it to you. But there is a missing bracelet that I've had. Well, it's been there since I came back from yesterday. It was on my desk. Somebody knock on the door. I'm tripping. Okay. All right, let's fill it in. Okay, so did you get what I got in my boxes? Is that what you got? So when I multiply this first one out, number one, these do not cancel because they're the same sign. So what I get from my first box is sine squared x minus 2 cosine sine plus a cosine squared. That's what I get from my first box. And this came because I added these together. -1 and -1 gives you a -2. Okay, in my second box, I have a sine squared plus 2 cosine sine plus cosine squared. And that equals 2. Okay, so let's look at what we have. Any ideas? What can I do? First, you always want to look for things that can cancel. So you're going to look to see, is there anything I can cancel out? Yep, I can cancel these out. Would you agree these two are opposites? Would you agree with that? So we can get rid of them. So now what I have left is a sine squared plus a cosine squared plus a sine squared plus a cosine squared, and that equals 2. That is. This is an identity. Remember, this equals 1. Sine squared plus cosine equals 1. This also equals 1. So what I end up with is 1 plus 1 equals 2, which is true. 2 equals 2. So I have verified that it will equal 2. That is correct. All right, so I think we're on page 6 in our notes. I'm not sure, but we're going to start summing difference now. So on your pink paper, can you flip it over to the side where it says this side is given to you? And it has like, yeah, flip it over to that side. So this is the side that we should be on right now. This side you do not need to memorize. It's going to be given to you, okay? And this is sum and difference identities, okay? So let's start off with the cosine sum and the cosine difference. So I believe, I don't know what page this is. Is this really page 6? I kind of guessed. I don't know. It's page 6. All right, let's go to page 6 in your notes. Now, in order to be consistent, because we're always going to use 2 angles on our unit circle, so to be consistent, can you highlight or underline that alpha will always be the bigger angle and beta will always be the smaller angle? We're just going to be consistent. Even though for addition, it doesn't matter. We'll just be consistent and always say the bigger angle is alpha. Okay. So let's start off with finding the exact value of the cosine of 75. Now, would you agree with me that 75 degrees is not an angle on our unit circle? Who agrees? So, in order to get the exact value, we need to use an identity. So, if we wanted to do the sum identity, let's start off with cosine sum. So I'm using this identity right here that's on your pink sheet. We need to find 2 angles on our unit circle that add to 75. So any idea of 2 angles that are on my unit circle that I can add together to get 75, 45 and 30, I agree. So what I'm going to do is I'm going to take the cosine and I'm going to put 45 first, 30 second. So my alpha angle is 45 and my beta angle is 30. So I'm not using this one. So what that means is every place in this identity where you see an alpha, I want you to put a 45 in this spot. And every place where you see a 30, which is beta, I want you to put a 30 in this spot. So let's go ahead and write it out. So I'm going to take, oh, hi. So we have the cosine of 45. Yeah. Now, it doesn't have to be Because would you agree that 30 plus 45 is the same as 45 plus 30? But I want us to be consistent. So we're always going to pick the bigger angle and call that alpha. Okay, so we got the cosine. Let's start off with this. It says cosine of alpha. So that would be cosine of 45. Multiply that by the cosine of beta, which is the cosine of 30, minus the sine of alpha times the sine of beta. So on your unit circle, I want you to find these four values. Fill it in. Find the cosine of 45, the cosine of 30, the sine of 45, the sine of 30. Okay, make sure that that's right because I don't have my unit circle. Did you all get that? Okay, so we're going to multiply first because that's order of operations. You can multiply two radicals together. So you can take the 2 times 3. So root 2 times root 3 is actually root 6. And 2 times 2 is 4. Minus, you multiply these together. Root 2 times 1 is root 2. And 2 times 2 is 4. So you would have root 2 over 4. Now we have a common denominator, but you cannot subtract radicals if they're not the same. So this does not give you root 4. They cannot be combined. They're not like terms. So it's going to stay root 6 minus root 2 all over 4. And that would be your final answer. On the test, you could do cosine difference also. If you could find two angles that would subtract to give you 75, you have that option. It's just going to say use the sum or difference formula. Okay, all right. Now we got an angle in radians, which is a little trickier. So what I do is, this is a 1. So I start off with, what do I do? I forgot. Oh, I know what I do. So we need to find two numbers that can subtract to give us 1. There's a lot of options. We could do 3 minus 2, right? Do you agree that 3 minus 2 is 1? If I put these both over 12, that would become a pi over 4 minus a pi over 6. So that's my option. That's one option. If you don't want to do 3 minus 2, you could do 4 minus 3. And you put both of those over 12. That'll give you a pi over 3 minus a pi over 4. So we have a lot of options that we can use. All right, there's a lot of different options we could do. We could do 9 minus 8. But you need to find two angles that when you subtract and then you reduce it, you get pi over 12. So what do we want to do? Which one do we want to do? Do we want to do pi over 4 minus pi over 6 or pi over 3 minus pi over 4? You get the same answer. It does not matter. All right, I heard Kamaya first. She said pi over 4 minus pi over, is that what you said? Pi over 4 minus pi over 6? All right, pi over 3 minus pi over 4. So which one of these is bigger on your unit circle? Which one is the bigger angle? Pi over 3 or pi over 4? So this is my alpha, and this is my beta. And this time, because I'm doing a cosine difference, I'm doing cosine with subtraction. I'm not using this one. You're going to find this one on your unit, on your pink sheet, which says you're going to take the cosine of your bigger angle, which is pi over 3, times the cosine of your smaller angle, which is pi over 4. And now we're adding it to the sine of pi over 3 times the sine of pi over 4. So go ahead and on your unit circle, find those 4 values and simplify it. Okay, cosine of pi over 3 would be 1/2, right? Okay, and cosine of pi over 4 plus sine of pi over 3 times the sine of pi over 4, which is going to give you root 2 plus root 6 all over 4. And that would be your final answer. That'll be it. What y'all thinking? I told you the rest of this chapter is not hard. It's 7-4. It's verifying. That's why that's the one you don't want to cheat on. That's going to hurt you. Come March 19th. It's going to hurt you for real. Especially because I'm pretty sure that some of those same questions is on the quiz from homework 10. Okay. Number 3, we have to figure out what identity it follows. So we have to figure out what identity says take cosine times cosine minus sine times sine. And we know it's one of these. So which one says cosine, cosine minus sine, sine? Is it the addition or the subtraction identity? Addition. So we're using cosine sum. So this is the cosine sum identity, which means that this is alpha and this is beta. So we have the cosine of 70 plus 20, which would give us the cosine of 90. And what is the cosine of 90 degrees? 0. So that would be your answer. Okay, now let's talk about sine. So now let's talk about the sine sum and difference. So now we have to figure out Is it easier to add to get 7 over 12 or subtract to get 7 over 12? For the first one, I want us to do sum. So I need numbers that can add to 7. You don't have to write this down. So we could do 1 plus 6 over 12. This will come down to be 1 over 2. But do we have a pi over 12 on our unit circle? All right, so we can't use that. So we did 1 plus 6. What else can I add to get 7? What'd you say? 3 and 4? 3 and 4. So what if I do 3 pi over 12 plus 4 pi over 12? What would that reduce down to? What is 3 pi over 12 reduced down to? Pi over 4. And what is 4 pi over 12 reduced down to? All right, which one is bigger on your unit circle? Is pi over 4 bigger or is pi over 3 bigger? All right, so this is my alpha and this is beta. And we're doing sum, so we're following this one right here, not this one. Okay. So we have the sine of alpha, which is pi over 3. We're going to multiply that by the cosine of beta. And then we're adding to that the cosine of alpha times the sine of beta. All right, go to your unit circle and let's fill in all 4. You're going to notice a lot of your answers look the same. It's going to be a root 6 and a root 2 over 4. Pretty much. And that would be my final answer. Just like that. Now to get for number 2, to get 15, we have a lot of options. We could do 60 minus 45. We could do 45 minus 30. We could go to quadrant 2 and do 150 minus 135. Like there's a lot of different options, okay? To keep it simple though, let's just stick with what we used in this last example, which is pi over 3 and pi over 4, which is 60 minus 45. So if you take the sine of 60 minus 45, this is alpha, this is beta. So this time I'm subtracting, so I'm doing the sine difference formula. So that would be the sine of 60 times the cosine of 45 minus the cosine of 60 times the sine of 45. Go ahead and fill it all in from your unit circle. And you can check to see if you got what I got. You got it? All right. So the first number or the first angle is always alpha. So alpha is pi over 12. And beta is 7 pi over 12. So now that we know that, we need to figure out what identity, just like the last one, what identity does it follow? Does it follow sign sum or sign difference? So we're going to look at our two options here. And this one is a little tricky because it really could be either one. Because if we add it, we're going to get an angle on a unit circle. And if we subtract it, we get an angle on a unit circle. So this is the pattern. It says sine, cosine, minus cosine, sine. So which one of these does sine, cosine, minus cosine, sine? Which one is it? The subtraction identity. So this is following the sign difference, which means that we are taking the sine of pi over 12 minus 7 pi over 12, which is going to give us a negative angle. So we already have our common denominator. What do you get when you subtract 1 minus 7? What is 1 minus 7? So that would be a negative 6 pi over 12. What does that reduce down to? Negative 2? Not quite. Close. Negative pi over 6? What is it? Negative pi over 2? Okay. Now, remember on your unit circle, that means that I'm rotating this direction. So if I rotate 90 degrees this direction, what angle is this down here? What's the angle that you see down here on the unit circle? Did you say 6, 7? 270. 270. Which in radians is what? 3 pi over 2. So this is the same as saying, what is the sine of 3 pi over 2? It's the exact same thing. So what is the answer? What is the sine of 3 pi over 2 or negative pi over 2? Negative 1, and that is my final answer. Good job, children. Monday we'll do tangent. Tangent is always the cousin that brings the problem. So we're going to do that one Monday. We're going to start with a simplify and a verify, and then we're going to do tangent, sum and difference.